Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are talking each and every chapter so that you can accomplish your goal of getting 60 in the KCET 2025 exam. So I hope you have already followed the chapter discussion of dual nature of radiation and matter. Now we are going to solve all the PYQs from this chapter. Also, yesterday there was the KPL match number 6. I hope you played that match and let me know how much you have scored. To know your score, you have to check the video where I have done all the questions, all the solutions are done in that video. So I hope that you have watched that video as well. And if you are still new to the channel and you are wondering how you can join our KPL matches, you have to go to WhatsApp and follow our channel. The link is given in the description, where you can click on the bell icon so that whenever we are posting an update, you can get that notification as well. Now what is KPL? If you are asking, KPL is KCET Premier League, where we are giving you 30 balls and you have to score as much run as possible. Each ball you can score maximum 1 runs and minimum 0 runs. Okay, so you know what is it? It is a question paper of 30 questions. You can answer them, and once you answered, your scores will be determined based on how many corrects you have made. Okay, you can check the question paper link is still there in our channel. You can join our channel and download the question paper, solve it, and check the answer given in our channel as well. Now let's start with the dual nature of radiation and matter. Today we are solving the PYQs. So the first PYQ is an experiment to study the photoelectric effect, the observed variation of stopping potential with the frequency of incident radiation is as shown in the figure. The slope and y-intercept are respectively. So let us understand what is the question is talking about. So this graph is given and they have asked you to find the slope. Slope is basically, if you know this angle, theta, okay, we know that slope is basically tan theta, right? Oh my god, how can we answer that? And y-intercept is, if you draw it back, then this will be the y-intercept. This point is called y-intercept. As you can see from the given graph, y-intercept is negative. Now how can we solve this? This is a very complicated question. Nothing is given, no data is given. Okay, but we know that there is one more equation, Einstein's photoelectric equation, that gives that Kmax, or maximum kinetic energy of a photon, of an electron emitted by the photoelectric effect, is given by h nu minus h nu 0. Okay, this is the work function. Okay, and nu naught is the minimum frequency, threshold frequency, and this is the frequency for which you are plotting the graph, right? So this is nu naught, this is the nu naught value. Okay, and what else? Kmax, if you apply a potential V naught, okay, if the stopping potential is V naught, and then we can write this potential difference V naught in terms of Kmax as E V naught equals to h nu minus h nu 0, right? This we know. This much I have done in our lecture, that there are different variation of this equation. So we have already completed this. Now V naught equals to h by E nu minus h nu naught by E. Now why I am writing like this? Now what is this axis? Sir, V naught. No, not about in terms of V naught. I am asking what is the general axis. General axis is y axis. What is this axis? X axis, right? Now what is the general equation of a straight line? As you can see, this is a straight line. What is the most common general equation of a straight line? Y equals to mx plus c. Now if you remember in your maths class, what is m? M is nothing but the slope of the line, right? So slope of the line, that is m is equal to itself tan theta. So you don't need to calculate m is equal to tan theta here. So this is not required. This is just to distract you. And what is c? C is nothing but the y-intercept. C is here is the y-intercept. So if you compare this equation, you can see that instead of y, here is V0. Instead of x, here it is nu. Okay, so nu is along x-axis, v naught is along y-axis. So only thing that you can write is y equals to this. If you compare these two equations, y is equal to mx plus c, then you can see that from this comparison you can simply write this as m equals to h by e. This is x, this is x, this is y, right? So y is equal to mx plus c. So x is nu, because this along this axis you are plotting the frequency nu, right? So you can simply compare and say this is m. This must be the m, right? And in the original formula, if you see, in the original formula it was given mx plus c, but in our equation it is coming out to be minus h nu by e, right? So from comparison we can write c equals to minus h nu naught by e. This is our y-intercept and this is our slope. Okay, so this is the simple answer. Okay, if you know this equation and if you rewrite this equation like this, then you can compare it and you can find the answer. Let's look into the options. So from the given option, which one is correct? H by e comma minus h nu naught by e. So correct answer is option D. Okay, in fact all the other options are clearly incorrect because they already including nu. Nu should not be in the equation because you are plotting along x-axis, you are already plotting nu. So nu should not be part of the equation. If you are smart, even without knowing this you can answer that. Okay, now let's move on. A 60-watt source emits monochromatic light of wavelength 662.5 nanometer. The number of photons emitted per second is. This is a little bit a long question, but not a very tricky question. It is easy question. So what is joule per second? What is joules per second? Now the energy of the source is given. Okay, energy of the source is given 60 watt, that is 60 joules per second, right? Now what is the energy of one photon? Suppose one photon is being emitted per second. What is the energy? We know that energy of one photon, okay, energy of one photon is h nu, right? H nu is the energy of one photon. Now how many photons are there? So let's say n number of photons are being emitted per second. Why per second is important? Because we have to cancel this per second. Okay, we want everything in terms of joules only, right? Energy is in terms of joules, but there is an extra per second is there because the unit is given as watt. Okay, so number of photons per second suppose is n. Then we can write E equals to times n. Now unit should be matched. So how we can match the units? We know that h is 6.62 times 10 to the power of minus 34. Okay, nu is c by lambda. C nu is, I am not writing explicitly. Okay, nu is c by lambda. Okay, c is 3 times 10 to the power of 8 and lambda is given here as 662.5 nanometer. So it will be 662.5 times 10 to the power of minus 9. Okay, and times n. Okay, now these two energies should be equal. These two energies should be equal. So we can write on our left hand side 60 equals to 6.62, okay, times 3 divided by 662.5, okay, times n times 10 to the power of minus 34 plus 8, and this was in the denominator, so it will go up and it will become plus. So I have told you multiple times. Now if you cancel this, if you see this number is 6.62 and here it is 662. So approximately we can cancel this and write this to be 100. Okay, this is the approximated calculation. As we know, we are not supposed to use calculator, so you have to use your brain to do approximated calculations. So it will be 10 to the power of minus 17. Okay, so 10 to the power of minus 17, minus 17, yes. So now there was now 2 zeros extra appeared. So you have to write it as 3n times 10 to the power of minus 19. Okay, 3n equals to 10 to the power of times 10 to the power minus 19. Now 3n equals to 60 times 10 to the power of plus 19. This will go on the right hand side. Our left hand side was always 60, right? So what we have to do, we have to take this on the other side, so it will become plus. Now you can cancel this, it will be 20. So n equals to 2 times 10 to the power of 20. If you take this 0 out and if you put it here, it will become 20. So 2 times 10 to the power of 20, very nice answer. So we can just simply tick it, option A is the correct answer, right? Now question number 3, and if you want to solve these questions on your own, you can pause the video, solve it, and then you can check the solution. I am suggesting that in a photoelectric experiment, if both the intensity and frequency of the incident light are doubled, okay, both intensity and frequency both are getting doubled, okay, the saturation photoelectric current, how it will change. So saturation current depends only on the intensity of light, whereas maximum kinetic energy of the photoelectron depends only on frequency. Okay, so saturation current depends only on intensity. Now if you double the intensity, no matter how you change the frequency, okay, it will be doubled. Okay, you should remember that kinetic energy depends only on the energy of the photon, that is frequency, and photoelectric current, saturation photoelectric current depends only on the intensity. So if you increase the intensity, current will be doubled, not quadrupled. Okay, now the kinetic energy of the photoelectrons is increased by 0.52 electron volt when the wavelength of the incident light is changed from 500 nanometer to another wavelength, which is approximately. Now this is a little lengthy question. So what is the kinetic energy? We know that kinetic energy K max, okay, first suppose K max 1 is equals to H nu 1 minus H nu 0. Now if the material remains same, this nu naught value will remain same. Now after some time you change the value, okay, K max 2, so it will become H nu 2 minus H nu naught. Okay, now it is increases by means what you have to do, you have to find the difference between K max 2 minus K max 1. Now I am going to show you one of the intelligent answer for this. Okay, so if you see K max 2 minus K max 1, H nu naught, in one case it will be positive, in another case it will be negative because of the negative sign in between, so they will cancel, right? So you will get H common nu 2 minus nu 1. Okay, so this is the basic part, this is the starting part. Okay, or equals to, now what is nu? Nu is C by lambda, right? We already know that, so we will use that fact. So C is common for both nu 2 and nu 1, so C will be common, 1 by lambda 2 minus 1 by lambda 1, and this value is given as 0.52. So it is plus, it is greater than 1. Okay, now it is greater than 1 means you are subtracting two numbers. Okay, you are subtracting two numbers and the result is positive. That means this should be greater than this. So from here this is just just for this problem only. Okay, I will solve the entire problem as well, but I am giving you one hint. If similar question comes, then you can answer them without going into the mathematical part. So basically this number is greater than 0. So this is like your inequalities. If you have done inequality problems, you know this kind of problems, right? This kind of equations. So this is greater than 0. That means 1 by lambda 2 should be greater than equals to lambda 1, 1 by lambda 1, or you can write this as lambda 2 should be less than lambda 1, right? Inequality equation. So now if you see all the options, okay, lambda 1 is given as, so lambda 2 should be less than 500, right? Lambda 1's value is given as 500. Now if you see all the options, only one option is less than 500, so correct answer is 400. So from here you can answer it 400. Okay, but in case In case they give all the values less than 500 or maybe 2 or 3 values less than 500, then how to solve it? So that is also I am going to solve it. That's why I am going to solve this problem. Otherwise I would have leave it here. Okay, but you should remember this shortcut trick. Okay, this is for particularly valid for this problem based on the options. Okay, and now since this is a little complicated problem, this kind of problems will always come with a catch, where if you use your brain a little bit, then you can solve these questions without even going into deeper mathematical calculations. Okay, now h is 6.62 times 10 to the power of minus 34. Okay, and c is 3 times 10 to the power of minus 8. Now if you consider this, there is one more shortcut here. Okay, what is the other shortcut? That hc in terms of nanometers can be written as 1240. Okay, hc is equals to 1240 electron volt, okay, nanometer. Okay, so electron volt nanometer, this is a special unit. You can remember this value. It comes very often in this chapter and atoms and molecules chapter as well. This is very common value. So 1240, someone uses 1242, everything is fine. 1240 is also fine, but 1240 is round figure, so I prefer 1240. Now now your answer will be converted into EV. Your left hand side also has EV, so right hand side will also have EV now. So you don't need to do much of calculations. You don't have to put the values of H, then C, then again convert lambdas into meters, then again convert 0.52 into joules. Then that will be a very complicated solution. Okay, so for when the data is given in terms of nanometers, when the data is given in terms of EV, you can use this converting factor. Okay, so now what is 1 by lambda 2? We don't know. What is 1 by lambda 1? 1 by lambda 1 is 500. Okay, or you can write this as 1 by lambda 2 minus 1 by 500 equals to 0.52 divided by 1240. Okay, now this is not so easy calculation. It will be little bit complicated and a lot of approximation we need to do as well. So that's why I said if this kind of questions comes, there will always be a process where you can solve it without using much calculation, but for that you have to use your head. Okay, so if you use your head, then you should be able to get the answer. So it will be 1 by 500 plus 1 by 500 plus, now what is this value? So 0.52, you can assume 0.52 to be 0.5 only. Okay, so it will be, you can consider this 0.5 and 1240. Okay, so what is 0.5? 0.5 is 1 by 2, right? So 1 by 2 means it will be 2 times 1240, or this will become 1 by 2480. Okay, 2480. Now 2480, you can assume this is almost equals to 2500, right? Why we assume that? Because there is a 500, so our calculations will be easier. So 2500 is the LCM. So 2500 means what is 4, 5 5s are 25 plus 1. Right, so what is the value? You can write this as 6 by 2500. Okay, or this is 1 by lambda 2. Problem is not done yet. So lambda 2 will be equals to 2500 divided by 6. Okay, so 4 6 are 25. Okay, 4 6 are 25, then 1 10 is there, so 6 ones are 10, and then there will be 40. 40 means 6 6 are 36. Okay, approximately 416. So approximate value of lambda 2 is 416 nanometers. Okay, from the given option 400 nanometers is the correct answer, right? So this is a way of solving it with all the methods, and also I taught you one shortcut method. Now let's move on to the next question. The de Broglie wavelength of a particle of kinetic energy K is lambda. The wavelength of the particle if its kinetic energy is K by 4. Now if you remember, de Broglie wavelength is given by lambda is equal to h by p. What is p? P is the momentum. Okay, also we say that P is nothing but square root of 2m K. K is kinetic energy, right? These are the very common formulas. I derived this formula once again in our last lecture. Also, this is there in your first PU. If you have missed it, you can go back and check dual nature of radiation and matter part 2. There I have derived this equation once again. I am not going to do it today because today we are learning how to solve questions quickly. So initially the kinetic energy is K, so we can write lambda is equal to square root of 2mk. Okay, now for the second wavelength, say the wavelength is lambda dash. Now what is lambda dash? Lambda dash is h by square root of 2m k by 4. Okay, so k by 4. So what will happen to that? H by square root of 2mk will remain 2mk. Now by 4, that by 4 will become 2. It will come out of the square root because this by 4 was inside the square root. So it will come out of the square root and it will become by 2. Now this is at the bit below, so it will go up and it will become 2h by square root of 2mk. Now what is this value? H by 2mk. If you see here, h by 2mk is lambda. So we can write lambda dash is equal to 2 lambda. So this is the correct answer. So correct answer is 2 lambda. That is option D. This is a simple question. Okay, if you know this formula, you can solve it without using too much difficulty, right? Now, the work function of a metal is 1 electron volt. Light of wavelength 3000 angstrom is incident on the metal surface. The velocity of the emitted photoelectrons will be. So what is the problem? We have to use Einstein's photoelectric equation. So K max equals to h nu minus phi naught. Okay. Now what is h nu? H nu is now here, since if you see the options, everything is given in meter per second, right? So there is no option, you have to convert everything into SI unit. So you have to start with the formula that h c by lambda, nu is c by lambda, okay, and phi naught is given 1 electron volt. So what we will do initially, let us see if we can do anything good, assuming the conversion ratio of Hc equals to 1240 by 1240, Hc equals to 1240 EV by EV nanometer. If we can get any good relationship, then at the end we will just need to multiply 1.6 times 10 to the power minus 19, right? But for now let us use that value. Okay, so but here wavelength is given 3000 angstrom. So 3000 angstrom equals to 300 nanometer. So if you are using this value, you have to be careful. You have to put the correct value. So 1240 divided by 300 minus 1. This is the K max. Okay. Now what is K? 0 cancels. So what you can do, you can take, even you can approximate this 124 to be 120 and divided it by 30. So you will get 4 minus 1. So 4 minus 1 is 3 EV. Okay. So our K max, we have achieved the K max in 3 EV. Now what is K max? K max is half m of electron v square Okay, we are trying to find this V, that is equals to 3 eV, right? Now we have to put the values. So ME is 9.31, 9.1. For simplicity I am assuming that's simply 9. Okay, you will see why. So 9 times 10 to the power of minus 31, okay, V square is equal to 3 times 1.6 times 10 to the power of minus 19. So EV to joule, you have to convert EV to joule. That for that you have to multiply 1.6 times 10 to the power of minus 19. So all the data are a little bit complicated. As soon as you are doing it in your using your own hand, you will feel comfortable. Otherwise it will be difficult for you to understand. So V square equals to 3 times 2 times 1.6 divided by 9 times 10 to the power of minus 19 plus 31. Okay, so 3. Okay, and what else we can do? If you assume this 1.5, then even we can assume we can simplify this as well, 0.5. Okay, so 0.5. So 0.5 into 2 is 1 times 10 to the power of, what is the value? 31 plus 31 minus 19. So it will be 12, 10 to the power of 12. So V square is 10 to the power of 12. So V will be square root of that, that is 12 by 2. So it will be 10 to the power of 6. So V is 10 to the power of 6 meter per second. Okay. So using all the approximations, all the correct approximations, we have able to solve it. Maybe little bit more than 1 minute, but if you are practicing it and if I am explaining it while solving, but you don't need to explain that. You have to understand the problem yourself and then you can solve it less than 1 minute. Okay. Now let's move on. A proton moving with a momentum P1 has a kinetic energy 1/8 of its rest mass energy. Another light photon having energy equal to the kinetic energy of the proton, okay, possesses a momentum P2. Then the ratio of P1 minus P2 by P1 is. So let us first see what is everything is given. So momentum of the proton is P1 and it is a 1/8 of its rest mass energy. Now we will study that in our nuclear energy chapter, that rest mass energy of any object is nothing but its mass times c square. Okay, E is equal to mc square. Yes, I know you have learned this equation, but you don't know what is rest mass energy represents. This energy is called rest mass energy. So even if an object is at rest, okay, it possesses some energy. That energy is called its rest mass energy, and that is nothing but mc square. Okay, so momentum P1 has a kinetic energy. So we know that momentum is nothing but 1 by root m k, right? Now k is what is k here? K is 1/8 of rest mass energy, right? So rest mass energy is mc square, so kinetic energy should be 1/8 mc square. So P1 is equals to 2m, okay, times 1/8 mc square, right? Now if you simplify this, you will get 1/4, yes, it will cancel 4, 1/4 m square c square, or P1 equals to 1/2 mc. Okay, so this is clear. Now they have said that another light photon having energy equals to the kinetic energy of the proton possesses a momentum P2. Now what is the now the de Broglie wavelength of the photon is given by, de Broglie wavelength of the photon is given by h by P2. Wait, right? Its momentum is P2, and we know that de Broglie wavelength is h by P2. Also, what is the energy? So energy of a photon is given by h nu. Now what is nu? Nu is c by lambda, right? So nu is C by lambda. Also, this is equals to the same energy that of this photon, right? So, proton. So, 1 by 8 mc square, right? So, these are all same. Now, let us put the values. So, hc divided by, what is lambda? Lambda is h by p2. So, h by p2 equals to half 1 by 8 mc square, right? Now this h will cancel and this p2 will go up. So p2c equals to 1 by 8 mc square. Okay, so this c and 1 c will cancel. So p2 is 1 by 8 mc. Okay, so we have calculated P2. Already know P1. Now we have to calculate this P1 minus P2 by P1. Okay, so what is P1 minus P2? P1 minus P2 is half minus 1 by 8. MC will cancel from both sides, right? So we can write this as half minus 1 by 8 divided by half. Okay, so this will become, what is half minus 1 by 8? Half minus 1 by 8, LCM will be 8. Okay, so it will be 4 minus 1 divided by half. Okay, so it will become 3 by 8 times 2. So it will be 3 by 4. So this is the final calculation. So correct answer is 3 by 4. Okay, little longer calculation, little longer problem, but very intelligent problem, very interesting problem. I like this problem very much because it has a lot of interrelations between different concepts. Now according to Einstein's photoelectric equation, the graph between kinetic energy and of photoelectrons ejected and the frequency of the incident radiation. So kinetic energy time versus frequency. So what is the equation? At the first problem I told you K max equals to h nu minus h nu 0. So from this equation they have asked you to plot K max versus nu. So this follows y is equal to mx plus c formula. So it will definitely be a straight line. And what type of straight line? Okay, the intercept is negative. So intercept is negative only in this equation, in this graph. So this is the correct answer. Okay, so Ke along y axis, frequency along x axis, and it has a negative interception. Negative interception means the graph will intercept it in the negative side. So this is only the correct answer. Now question number 9. The following graph represents the variation of photocurrent with the anode potential for a metal surface. Here I1, I2, I3 represents the intensities and nu1, nu2, nu3 represents the frequency for curves 1, 2, 3 respectively. Then which of the following is correct? So let us first understand what is the relationship here. Okay, now if you see in this graph, 1 and 2 both have the same frequency. Okay, they have the same potential. Okay, stopping potential, same stopping potential means they should have the same frequency. So first of all, nu1 should be equals to nu2, no doubt about it. Okay, and if you consider 3 and 2, 3 is going here, 2 is also going here. That means they are reaching at the same saturation photocurrent. So intensity of 3 and 2 should be equal. Okay, so intensity of 3 and 2 should be equal and frequency of 1 and 2 should be equal. Now let us check all the options given here. So first of all, let us check where all nu1 is equal to nu2 is given. So nu1 is equal to nu2 given in the first equation, but here they have also said I1 is equal to I2, but that is not correct. I1 and I2 are not correct because if I1 is equal to I2, then they would have same saturation current, but that is not there. They have different saturation current, then intensity should not be equal, right? And what else? They have given one more nu1 is equal to nu2, that is option C. So nu1 is equal to nu2 and I1 is not equals to I2, right? So this should be the correct answer. They have not given I3 is equal to I2 here, but they have said that I1 and I2 are not equal. So this should be the correct answer in this case. Now let us look into the next question. Light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. If both the frequency and intensity are doubled, the photoelectric saturation current is the same question as we have seen. Photoelectric saturation current depends only on intensity, and if you double the intensity, it will be doubled, not quadrupled, not 4 times, only doubled. The number of photons falling per second on a completely darkened plate to produce a force of 6.62 times 10 to the power of minus 5 Newton is n. The wavelength of the light falling is 10 to the power 5 times 10 to the power of minus 7 meter. Then n equals to given value. Okay, this is very interesting question. Okay, we know that force is rate of change of momentum, right? Rate of change of momentum. Now what we have to do, we have to find the momentum of the incident radiation. Okay, what is the momentum they are imparting on the subject. Okay, if we can find the momentum they are imparting, then we can find the force, right? So per second means dt term is already taken care of. Per second, as I already said, per second means dt term is already taken care of, and if the entire photon is being absorbed by the darkened surface, then entire energy is dp. So rate of change of momentum itself is p. So what is p? P is nothing but h by lambda, right? So momentum of particle with the motion is given by h by lambda. So it is 6.62 times 10 to the power of minus 34. Okay, and wavelength is given by 5 times 10 to the power of minus 7. Okay, so what we can do, I am not touching this value yet, you will see why. So 10 to the power of minus 27. Okay, minus 34 minus 7 in the below, so you will go up, it will become plus minus 27. So this is the momentum. Now force, suppose this is for one photon, this is for one photon. Now if there are n number of photons, then the total force should be equals to n dp by dt. Okay, this itself is dp. Why this is dp? Because once, suppose there is a collision, you remember the collision problem, a ball was moving with a high velocity, then suddenly it collided with the medium and it comes to a stop. So the entire momentum of that object is transferred into the second body, right? So same thing is happening here. So entire momentum of the photon is transferred into the second body. So the final momentum is 0. So the change in momentum is p minus 0. So this is the change in momentum. Okay, if you still don't understand, don't forget to mention that in the comment below. Okay, I will try to explain if required. Now what is f? F is given 6.62 times 10 to the power of minus 5. So that is equals to n is n times 6.62 by 5 times 10 to the power of minus 27. Okay, so 6.62 and 6.62 cancels. That's why I have not done that. Okay, so now, sorry, this is 10 to the power of minus 7. My mistake. Okay, so you can write this as n equals to 5 times 10 to the power of 20. Sorry. This is 10 to the power of minus 5. Right, 10 to the power of minus 5 was here. And then we can write this as 5 times 10 to the power of 22. This will come on that side, so it will become plus, and there was a minus. this was in the denominator, it will go up and it will become plus. So these are all the things that you have to practice. Okay, if you are still not be able to understand why this is 5 times 10 to the power 12, 22, you have to practice more kind of numericals. Okay, so then you will be able to answer this. So 10 to the power 22 is already given here, so 5 is given. So even if you are practicing for JEE, this kind of question is very common in numerical section. You know, they will give you a value like that and then will ask you what is the numerical answer. Answer will be 5. The exact value will not be there because they will change the data so that you don't get the exact answer. The maximum kinetic energy of the emitted photoelectrons depend on. So maximum, I said maximum kinetic energy depends only on frequency, whereas saturation photocurrent depends on the intensity, right? So frequency of the incident radiation, so only frequency of the radiation, right? Proton and an alpha particle are accelerated through the same potential difference V. The ratio of their de Broglie wavelength is. Now you should know that alpha particle has mass 4 times that of proton and charge of an alpha particle is 2 times that of proton, that is 2e. Okay, so these are the things that you should know. Now what is the energy when they are getting accelerated in the potential V? So energy of the proton is QV, that is EV. Okay, now what is the momentum? Momentum, we know that momentum of a proton is given by square root of 2m. I think you should be familiar with by now. So 2m times EV, proton mass of a proton, right? Now what will be the momentum of alpha? Using the same logic, we can use the same logic and calculate the momentum of the alpha particle. Okay, 2m alpha times q alpha v. Okay, so we have intentionally written everything in terms of alpha. So now let us put the values. M alpha is 4 mp. Okay, if you are not aware of alpha particle, we will learn about basic alpha particle in our upcoming chapter. Okay, where we are doing Avogadro experiments. Rutherford experiment. There we will know about alpha particle. So this is also little bit mixed concept, but not too much. We can solve it. So 2e, q alpha is 2e times same potential. Okay, now what is the de Broglie wavelength for proton? De Broglie wavelength is h by p. Okay, what is the de Broglie wavelength for alpha? h by p alpha. Okay, so what is the de Broglie wavelength of the ratio? Ratio is alpha p divided by alpha alpha. There is a plant called alpha alpha, you know. So p alpha divided by pp. Okay, so it is on the denominator, so it will go up, right? I hope you understand that. So p alpha is nothing but the entire thing, 2 times 4 mp times 2 ev, and pp is 2 mp ev. So 2 mp mp vv, they are all cancelled. Okay, even though they are inside the roots, you can take the common root and you can still cancel them, right? So they are all cancelled. So denominator, nothing is there, so denominator is 1 now. What is numerator? Numerator is 4 times 2. Okay, so square root of 8. Square root of 8 means 4 times 2, 4 means 2 root 2. Okay, so the correct answer is option B. Okay, understood? Now let's move on. An electron is moving with an initial velocity v is equal to v naught I and is in a uniform magnetic field B is equal to B naught J. Then the de Broglie wavelength. Very interesting question. You might be thinking, oh my god, this is a very difficult question. We have to calculate the force acting QBV, then we have to do something, but nothing. What is the de Broglie wavelength? De Broglie wavelength is nothing but h by p. And what is p? P is mv. Okay, even though the direction, and in this case V is constant, it is unidirectional and it is acting on a its magnitude is also constant. This magnitude wise also it is not changing. So what we can say, P is constant. P is constant means what? If P is constant, H is obviously Planck's constant, lambda should be constant, right? So it remains constant. Okay, you don't need to worry too much. If the question looks difficult, actually it is easy. If the question looks easy, maybe it is difficult. Okay. A particle is dropped from a height h. The de Broglie wavelength of the particle depends on the height s. Now, if you drop a particle from a height h, okay, when it reaches to the ground, so you dropped it from a height h. Okay, when it reaches to the ground, at just before touching the ground, what is the velocity? Suppose the velocity is v. Okay, so we know that from the conservation of energy, half m v square is equal to m g h. M cancels, so v is equals to square root of 2 gh, right? So then what is the momentum? Momentum is mv, that is m times square root of 2gh. Now what is de Broglie wavelength? De Broglie wavelength is h by mv, h by p or h by mv, no matter how you write. So h by m times square root of 2gh. Now remember, this is Planck's constant, this is height, they are not same, so you cannot cancel them with each other. So how lambda is dependent on h? So lambda is proportional to h to the power minus half, right? So lambda you can write from here, lambda proportional to 1 by square root of h. So square root of h means to the power half and 1 by means minus half, so it will be h to the power minus half. Okay, not difficult question. Now from the following graph, this is the graph of photocurrent against collector plate potential, the two different intensities of light I1 and I2. One can conclude that, so they have given two different intensities I1 and I2. Okay, now this is giving a higher saturation current, this is giving a lower saturation current, right? So higher saturation current means intensity must be greater. So I2 must be greater than I1. So I2 must be greater than I1. So here they have given I1 less than I2. So the correct answer is option C. Okay, definitely they are not equal. Definitely I1 is not greater. Only possibility is I2 should be greater than I1, right? Next question. The variation of photocurrent with collector potential for different frequencies of incident radiation nu1, nu2 and nu3 is as shown in the graph. Then now here they have given you a graph where frequencies are changing and they have asked you what is the possible relationship. Now if you see that this nu3 has the highest stopping potential. Highest stopping potential means it should have the highest energy. Now highest energy means what? Frequency should be highest. We know that K max equal to H nu minus H nu 0. So we know this relation K max, or in terms of stopping potential, in terms of stopping potential we also know that EV naught is equal to H nu minus H nu naught, right? Now if the material is same, the H nu naught is constant, right? So only thing is V naught is directly proportional to nu. So if V naught is, magnitude of the V naught is more, that means nu should be more, right? So in this case, as you can see, here we have highest V naught, highest V naught means nu3 should be highest. So nu3 should be highest, nu2 will be in between and nu1 will be last. Okay, so here from the given option we can write nu1 should be the smallest, nu2 should be in between and nu3 should be the highest. Okay, so correct answer is option C, right? Now let's move on. The de Broglie wavelength of an electron accelerated to a potential of 400 volt is approximately. Now this is a painful problem. This type of questions was very common pre-pandemic, okay, pre-pandemic years, this type of one question used to come almost every year. Nowadays, all till the questions that we have solved, we have not encountered these questions so many times, right? So these questions are not coming, not very often, but if this kind of question comes, you have to solve it. So I am going to tell you the how to answer it, but it is a little bit trickier unless they give a data which can be easily solved. Okay, the de Broglie wavelength of an electron accelerated to a potential of 400 volts. So first of all, what is the energy of the electron? Energy of the electron is EV. Okay, whenever an electron is accelerated, its potential is given by EV. Okay, now that energy is equals to its kinetic energy, that is half m of electron velocity v square. Okay, from here we have to find the velocity, then we have to calculate the momentum. Momentum is P is equal to mv, right? P equals to mv. If we can find v, we can write mv, and then we can answer this question, right? So let us use the value. E is 1.6 times 10 to the power of minus 19, okay, and V is 400 volts, okay. Half m is 9 times 10 to the power of minus 31. Now you might say, sir, it is 9.31, why you are writing 9? The value is so small, taking small adjustments here and there does not matter, okay. As long as your answer is correct, it does not matter, okay. So now let us simplify this. So V square equals to 1.6 times 2, okay, this 2 comes here, that's why 2, times 400 divided by 9 times 10 to the power of minus 19 plus 31, so plus 12. Okay, so what we can do here, see, this value is not super good. Why not super good? Because there is a 2 here. We can partially do the square root, so we have to do the square root here. That's why I am saying this data is not super good. So V equals to 1.6. So square, first of all, square root of the entire thing, 1.6 times 2 times 400 times divided by 9 times 10 to the power of 6. This is 12. So after out of the square root 6. Now 1.6 can be written as 16 by 10, right? So 16 means what? 16 means square root of 4. Those who are writing 0.4, they are wrong. Okay, so 16 by 10. So that 4 comes out. 400 means 20. Okay, and divided by 9 means 3. Okay, times 10 to the power of 2 was here, and we have multiplied with 1 extra 10, so it will be here, right? Times 10 to the power of 6. Okay, so we can cancel this. So 80 by 3 times square root of 1 by 5. Okay, now here again we have to do some approximations. What approximation? 1 by root 5 means you can assume the 5 to be 4, so it will be 1 by 2. So you can write this as 80 by 3 times half times 10 to the power of 6. So this is a bad approximation, not super bad, but still not very common approximation. Okay. So you have calculated V. Now what is mV? Again, m is 9 times 10 to the power of minus 31 times V is coming out to be 40 by 3 times 10 to the power of 6, right? So this is the mV. So 3 cancels, 3 4s are 120 times 10 to the power of minus 31 plus 6 minus 25. Okay, so now what is the wavelength. Wavelength is nothing but h by p. Again h is 6 point. So for now assume it is as 6 only. Okay. So 6 times 10 to the power of minus 34 times 120 times 10 to the power of minus 25. Because there is 120 here, I am assuming it to be 0.6. Okay. So 0.6 only. So it will cancel 1 by 20. So you can write this as 10 to the power of minus 34 plus 10 to the power of 25. So 10 to the power of minus 9 divided by 20. Okay. So you can write this as 1 by 2 10 to the power of minus 10. Okay. Or you can write this as 0.5 times 10 to the power of minus 10. Now all the answers are given in terms of nanometers. So you have to do one more step, 0.05 times 10 to the power of minus 9 or 0.05 nanometer. I know it is a boring problem, but I can't help it. So from the given answer, since we have done a lot of approximation, you can say the correct answer will be 0.6. Okay. Now this is a very bad question, very bad problem where you have to do a lot of approximation which are not logical. Okay, they should have given the values, we should cancel these values and you get a good value. Okay, if they are doing that, then it's still fine problem. Otherwise, based on this current data, I don't think this is a very good problem. Okay, now let's look into the last this question. Light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively successively illuminate a metallic surface whose work function is 0.5 electron volt. Ratio of maximum speeds of the emitted electrons will be. So first of all, let us write the formula K max kinetic energy for first electron. Okay, what is the energy? First energy is 1 electron volt. And what is the work function? Work function is 0.5. So if you remember that K max is equal to h nu minus h nu naught, right? So this is the energy of the photon, and this is the work function, right? If you remember, this is the formula. So we have just simplified that and applied directly. So this is equals to 0.5. Okay, and K max 2. K max 2 is energy is 2.5. Okay, minus 0.5, so it is equals to 2. Okay. Now what is the K max? K max is half m of electron v square, right? So K max 1 will be half mu1 square v square, K max 2 will be half me v2 square. So basically if I write K max 1 divided by K max 2, that is basically v1 square divided by v2 square. Other terms will be cancelled. That is equals to 0.5 divided by 2. Okay, so v1 square by v2 square equals to 1 by 4. 0.5 means half. There is already 1 half, so it will be 1 by 4. So v1 by v2 equals to 1 by 2. Okay, so the ratio will be 1:2. Simple. Okay, this is an easy problem. This is a KCET level problem. Okay, this kind of questions may come in your upcoming exam as well. The maximum kinetic energy of the photoelectrons depends on frequency. So this is a very common question. Either they are asking intensity, what will happen to the saturation current, or they are asking what will happen to the maximum kinetic energy. This only depends on frequency. Okay. Now if you like this video, don't forget to share it with your friends, subscribe to our channel if you have not yet, and don't forget to join our WhatsApp group for KPL and more such informative videos. All the subjects are we are doing for your KCET 2025 preparation, and we are hoping that you will achieve your dream goal of scoring a very good rank in upcoming KCET 2025 exam. So far, goodbye. I'll be back with a new video tomorrow. Thank you for watching.